welcome back. Till now, we have learned basics of data structures and algorithms, which includes definition of data structure and algorithms. We also learned time and space complexity of algorithms, and in the last section, we have learned details of recursion. Now, from this section, we will start to learn data structures one by one and do practice using Python programming language. In this video, we will start to learn array data structure. It is the most used data structure. An array is a simple collection of objects or things. They are very powerful data structures that store list of elements, and they have endless applications. Simple examples can be collection of books on our table, clothes in our wardrobe, and pens in our pen stand. Let's quickly examine one of these real-life array structures to understand the logic behind the array. So here, we will look at this box of macarons. This box of macarons is very similar to array data structure. If we look at this box very carefully, we can easily see what properties of this box of macarons. Okay, first is it's a box of macarons which holds only macarons. This means that this box is produced for macarons. You cannot store, for example, cream puff in this box because it will not fit in. This box is produced only for storing macarons. The next property is that all macarons in this box are next to each other. There is no gap between them, which means that they are contiguous. The next property is each macaron over here can be identified uniquely based on their location. So let's say if we want to take this macaron over here, the location of this macaron is 1, 2, 3. So this is unique location for this. Then if we want to take this macaron from here, the location of this macaron will be 4. As you see, each of these macarons has its own location, which is unique. So the last property is that we cannot change the size of this box, which is fixed. This means that this box is produced by some standard manufacturer, and assume that there will be only 10 macarons. We cannot change the size of this box, or we cannot put 11 macarons inside this box. It is produced by standard manufacturer to hold only 10 macarons. So these are the common properties of this box, and we can easily see them if we look at carefully. So if we compare this box of macarons with the array structure, we see that they are very similar. So a typical array structure looks like this. Here we have 6 elements. Here you can easily see that the appearance of macaron box and array structure somehow looks like each other. Now let's look at the properties of this array, and we will see that they are similar to the properties of this box over here. So the first property is that array can store data of specified type. This means that when we create an array of integers, we cannot store string values in this array. So if we try to insert this value to this array, it will raise error. We cannot do that. So as you see, this property is kind of similar to this property, the first property of this box. Here, we can think that data type is macaron, so we cannot store this cream puff into this data because this is for macaron. So in array, the data type is integer. So if we want to store string value over here, it will raise an error and will not allow us to do so because this is how arrays work. Once you have defined the type of data for array, the elements must be the same type of the data that we defined. Okay, let's continue to the next property. The next property is elements of array are located in contiguous location in memory. This means that elements of array are next to each other. So there is no gap between them as we have in the macarons box. As you see, we don't have any gap here, and we don't have any gap between these elements. They are located next to each other. So the next property is each element of array has a unique index. As we have here, we have unique locations for these macarons, and we have unique indexes for each element of array. So if we want to access, for example, this element over here, we need to access through index of 2. And here take into account that indexes start from 0, not from 1. And their increases sequentially. So the last property is the size of array is predefined and cannot be modified. So here again, if you look at this box of macarons, we see that the size of this box is predefined. And this is applicable for array as well. When we create an array, we define its capacity, so we cannot change it later on. This is the biggest limitation on array. So this is all properties of array. As you see that it is somehow similar to the properties of this box over here. Hopefully you now have a picture of array, what it looks like. Now let's see what is the definition of an array in computer science. In computer science, an array is a data structure consists of a collection of elements, each identified by at least one array index or key. An array is stored such that the position of each element can be computed from its index by a mathematical formula. So here we have a collection of integers and each of them identified by array index. So based on these indexes, we can find any element and do any mathematical calculations on them. Now you might be interested, why do we need an array? So in software programs, the array is used almost everywhere in the program to store any data. Consider a situation where we need to store 3 integer numbers. If we use programming simple variable and data concept, we need 3 variables of integer and we can store our numbers in these variables. So we don't have any problem. It's very simple. Because we had to store just 3 integer numbers, so we don't have any problem. We can create 3 variables and store our 3 integer inside these variables. Here is okay. Now let's assume we have to store 500 integer numbers. Are we going to declare 500 variables? Of course not. So to handle such situation, almost all programming languages provide a concept called array. An array is a data structure which can store a fixed size collection of elements of the same data type. So instead of declaring 500 variables, we just need to declare an array with the type of integer, keep these variables inside array. Then later on, by using indexes of array, we can access these variables easily. And that's it. Hopefully, with this lecture, you have understood what's an array and why it's essential in programming. Now, in the next lecture, we will look at different types of array. Alright, in the last lecture, we have learned what's an array and why it is needed in programming. Now, in this video, we will look at different types of array. There are 2 types of array depending on the number of dimensions. So they can be one-dimensional or multidimensional. In multidimensional arrays, we can see that they can be 2-dimensional, 3-dimensional, 4-dimensional until n-dimensional. So let's see what we mean by this. The simplest type of array is linear array, which is also known one-dimensional array. One-dimensional array is an array with a bunch of values having been declared with single index, as you see over here. One-dimensional array is the one which has only one row and multiple columns. If we look at the format of the one-dimensional array, we can easily see that we have multiple columns here and one row. So how can we access an element of one-dimensional array? So one-dimensional array elements can be accessed using AI. So I is an index between 0 and n. So here you see that each element has its own index and these indexes are unique. So let's say if we want to access the number 10 from this array, we just need to write the array name and its index. The format will be like this. So first we put the name of array, then the index of element that we want to access. So let's say if we want to access 11 from here, we need to write array name again and its index. It's going to be something like this. Okay, let's continue to what's 2-dimensional array. Now in 1-dimensional array, we saw that it consists of one row and multiple columns. But here in 2-dimensional array, the number of rows is more than 1, which is represented typical matrix. This is an array with a bunch of values having been declared with double index. If you look at this picture, we can easily see that we have multiple columns and multiple rows here. And that's why it says that these numbers has been declared with double index. Each columns and each rows has its own index. If we look at 2-dimensional array carefully, we can easily see that 2-dimensional array is composed of 1-dimensional arrays. In this case, it seems that we have combined 3 1-dimensional array together and got a 2-dimensional array. And you might be wondering, why do we need 2-dimensional arrays when we have 1-dimensional array? So as you progress in this course, you will see that there are some scenarios that 2-dimensional arrays are very useful. Okay, let's see how can we access the elements of two-dimensional arrays. Here we have index of columns, and here we have index of rows. So to access an element in two-dimensional array, we will just first put the row number, then the column number. So for example, if we want to access an element over here, which is 20, we need to first look in which row it is located. We see that it's the row index here is 0. Then we will look at the column. The column index is 4, which means that to access this element over here, we need to write something like this. A0, 4. Here 0 is the index of row, and 4 is the index of column. Okay, let's give one more example. For example, if we want to access an element over here, which is 30, once again, we need to first look at row index. Row index here is 2, and then we look at column index. Column index is 5, which means that to access this element, we need to write something like this. Here is the array name, then the row index, and then column index. So with this, we can access elements of two-dimensional array. Here, the tricky moment is you need to first put row index, not column index. Okay, the next type array is three-dimensional array. It is similar to two-dimensional array. The only difference is we have depth over here. We can imagine three-dimensional array as multiple two-dimensional arrays. Here, values declared with 3 indexes, because we have depth over here. Three-dimensional array remind us a cube with numbers on it. If you look at this carefully, we can see that each face of cube is composed of two-dimensional arrays, which means that three-dimensional array is combination of two-dimensional arrays. Now, in the real world, one-dimensional and two-dimensional arrays are used broadly, but three-dimensional arrays are rarely used. Okay, let's see how can we access the elements of three-dimensional arrays. Let's say we want to access the number 2 on the right side. The first index we need to find is the depth of array, this way. So it starts from 0, 1, 2. So if you want to access this element over here, depth is 0. So the next thing that we need to find out is row number. So we see that row starts from here. So this is first row, this is second row, this is third row. So the first row's index is 0, which means that we will have 0, 0, 0. Then we need to find out column index. And the column shows like this. So first column, second column, and third column. The first column's index is 0, and the second column's index is 1, which means that to access this element over here, we need to write something like this. So A, then 0, 0 shows us the depth. First element here shows depth. Then we put row index. Row also is 0. And then we put column index. Column index is 1, 0, 1, 2. Okay, let's try one more example to make things more clear. So here we want to access this element over here. So to access this element over here, first we need to identify depth. So what's the depth of this element? If we start from here, 0, 1, 2, so depth is 2. So then we need to identify row index. So it's located on the top, which means that row index is 0. Then finally, we need to identify index of column. So column starts from here, 0, 1, 2, which means that it will be 2. So to access this element, we will need to write something like this. So here, 2 is the index of depth, 0 is the index of row, and the last 2 is index of column. Okay, that's it for types of array, and hopefully you understand the concept, and you know the types of arrays and how to access the elements of different types of array. Now in the next lecture, let's see how these arrays are located in the memory. Alright, in the last video we have talked about different types of arrays, and we have learned one-dimensional, two-dimensional, and three-dimensional arrays. Now in this video, let's see how these types of array represented in memory. Are they represented as shown here, or is it different? In this lecture, we will look at this. Okay, let's start with one-dimensional array. Let's say we have initialized this array over here, which consists of 9 elements. The first element is 5, the second is 4, then the third element is 10, and it continues like this. And the index of elements starts from this 0. Now let's see how it is stored in RAM. Let's say this is our RAM, which is random access memory. So when we initialize an array of 9 elements, the compiler allocates 9 contiguous cells in memory like this. So it can start from any location. This array can be over here, it can be over here, it can be over here. It doesn't matter. So based on system load, the compiler decides where to start. We as developers cannot do anything about this because it's up to the system from which location over here it will start this array. But the system guarantees that all these cells will be contiguously in the memory, which means that they will be located next to each other. This means that there will not be any gap between these cells over here. For example, 5 cannot be here and 4 cannot be here. If 5 is here, then 4 has to be over here. This means that these elements will be located next to each other, no gap between them. So this characteristic is guaranteed by the system. So you might be interested that why they must be located next to each other. So the answer is, this is the nature of array. If you look at our definition of array, it says that elements of array are located contiguously. This means that they have to be each other. There is no way that one element can be here, another can be here, then another can be here. All of them has to be together, next to each other. So the representation of one-dimensional array in the memory is very simple. Basically, the compiler allocates from any given cell and then allocates cells as the number of cells in the array that we initialize. So with this, it's clear that how one-dimensional array is located in the memory. Now let's see how two-dimensional array represented in the memory. Let's imagine that we have a two-dimensional array like this, which consists of 3 columns and 3 rows. Here in the last lecture we said that this is row 1, this is row 2, this is row 3. And the index of row 1 will start with 0, then 1, 2. And from here, this is column 1, and this is column 2, and this is column 3. And here also the index starts from 0, 1, 2. So we have two-dimensional array like this. So the question is it going to be like this in the memory as we show here, or it's going to be something different? So the answer is no. In the memory, it is represented as one-dimensional array. So how this is possible? Okay, let's see in the memory. This two-dimensional array will be represented like this. As you see, the first element is the element from two-dimensional array, which is row 0 and column 0. And the second element is row 0 and column 1. Then the third element is row 0 and column 2. Then it continues like this. Then the fourth element is row 1, column 0. Then the fifth is here row 1, column 1, and here row 1, column 2. It continues like this. As you see, if you look at this example very carefully, we can see that we took each row separately and combined them in one row. This is the first row from the two-dimensional list. You see this is the first row. This is the second row that comes from two-dimensional array. And this is the third row that comes from two-dimensional array, which is located here. So the system combined all of them and make like a one-dimensional array. So in the memory, it represented like this. Now, as you see, two-dimensional array is not located in the memory like this, as shown here. This is just for explanation for users to have a clear picture of it. So on a physical level, it's stored as one-dimensional array. Now it's clear how a two-dimensional array is represented in memory. Let's continue a three-dimensional array. Okay, let's say we have a three-dimensional array like this. Basically, this element over here is depth 0, row 0, column 0. Then it comes like this: depth 0, row 0, column 1. Then depth 0, row 0, column 2. And it continues like this: depth 0, row 1, column 0. Then depth 0, row 1, and column 1. And this element over here, depth 0, row 1, and column 2. And this continues like this. Let's see how this three-dimensional array represented in memory. Once again, it's going to be like one-dimensional array. It will be represented in a single row. So the first element here, this is the element comes from here, which is depth 0, row 0, and column 0. And it continues like this till the last element from the three-dimensional array. So one common thing about all three types of arrays in memory representation is that all elements are located contiguously, which means that you can never see an element is located here and the next element is located here. They have to be next to each other in any type of array. Now, hopefully you understand how different types of arrays are represented in physical memory. Apart from one-dimensional array, they are different from the way that we are showing the users that they expressed in the memory. So hopefully everything is clear now. Now in the next video, let's see the common operations that can be performed on arrays. Hi there. Now in the last video, we looked at how different types of arrays are represented in memory. Now in this video, we will look at how to create an array using Python programming language. Now before continuing to write code in Visual Studio Code, let's see how we can create an array. What are the steps to create an array? So when we create an array, we have 3 steps in most programming languages. First, we assign it to a variable, then define type of elements that it will store, and define its size. Now the last step is not applicable for some programming languages because now for dynamic arrays, we don't need to specify size. It's automatically set and get increased automatically when you add new element to the array. But this causes performance problems. So if we define an empty array, our array will look like this. There is no element inside this array. So when we create this array, we set the size of array. That's why all of that space in the memory is reserved from that moment on for future values that may you want to insert. For example, if we define an array of size 6, but we only insert these values over here, all remaining space will be empty and reserved in the memory. This is because arrays are extremely efficient in accessing values because all elements are stored in the contiguous spaces in memory, and with this way the computer knows exact location of requested information in the memory. So that's why it has to reserve these spaces for future usage. But there is a downside to this approach. We might reserve a memory for future operation that may not occur. So this is why arrays are recommended in situations when you know beforehand how many elements you are going to use. Otherwise, if you just reserve space in the memory, this causes memory leak. Now in the next lectures, we will dive into array operations and see how they are reflected in the memory. Now here, let's see how can we create an array in Python. Before doing so, I want to mention that in Python, arrays are not built in data structures. Instead of arrays, there is a list data structure, which is almost same as the array, but with some differences. We will talk about lists in the next section and discuss the difference between array and list. Now the question is, if we don't have arrays as built-in data structure, how can we create a typical array in Python? So the answer is array module. So we need to import this module every time when we use typical array. So the syntax for creating an array in Python using array module will be like this. First, we need to import array module. Then based on this array module, we can create an array. Here type code is data type and initializers array elements. So type codes in array module can be one of these. For example, when you create an array of integer, you need to put I and create here and initialize the elements. We will see it in Python. So these are the common types that we use in array module. Let's see how this is working in practice. Let's switch to Visual Studio Code and create one sample array. Here first I need to import array module. It's going to be like this. From array import everything. Then after importing this, I can create sample array like this. Array 1 equals array. Then here I'll put integer. Then I'll put numbers here. Let's put like this 1, 2, 3, 4, 5, and 6. This is a typical array, which is a type of integer. So if I just print this array, you will see this. It is created array. Okay, let's run this code. You see that our array is created and printed out. So this is our array here. If you want to create an array of, for example, double, you need to write like this. Array, I'll put like 2, then array. This name comes from here. If you import, for example, import array as any given name that you give, you need to change this name to the name that you gave there. So in this case, I haven't changed it. I'm using the standard format. That's why I put here array. Then inside, then here I will put b, and inside brackets I need to put double values. For example, 1.3, 1.5, 1.6. If I save it and print this array out, you'll see that our array is successfully created. This is the array type of double. So everything is clear for this. Now let's see what's the time complexity of array creation. Complexity of array creation is a constant time operation because here we are just creating an array and initializing the values upfront. But in some programming language, when you define the size of array and create an array as a empty array. Then assigning values one by one will take O(n) time complexity, but in this case it's O(1) time complexity, which is constant time operation. So now you saw how we can create a typical array in Python. Hopefully everything is clear now. In the next video, let's look at how can we insert a value to the array. Hi there. Now in the previous video, we have learned how to create an array and what happens in the memory when we create an array. Now in this video, let's look at inserting a new value to the array. Okay, let's say we have an array of size 6. 3 of the cells are empty. Now if we want to insert an element over here, we just need to point the index of this cell and assign the value to it, like this. We are putting the array name and index, which is 3 over here, and the value that we want to insert. For example, if we want to insert a value over here, we just need to again specify the index and the value that we need to insert. So as you see that inserting a value to the array when we have empty cells is very easy. Now let's say we have an array like this, and we want to insert an element in the beginning of array, but there's a problem here. The first index, which is 0, is already reserved. There's a value over here. How can we insert a value at the beginning of array? So to do so, to insert an element at the beginning of an array, we move all elements located to the right of insertion site, one index to the right. So in this case, A will move here, and B will move here, and C will move here, and D will move here, and E will move here, which means that the index of A will become 1, and the index of B will become 2, and so on. It's going like this. Then after moving all elements, we can insert this element over here, because this cell over here will be empty. So the insertion will be completed like this. But this process is very time-consuming process, because imagine that if we have million elements, so we have to move all elements to the right, and which is very time-consuming operation. Okay, now here you might have an interesting question. What happens if the array is full? How do we insert an element in the beginning of array? We want to insert this element here, and we see that there is no place at the end, so we cannot move all elements to the right side. So what will happen in this case? So in this case, we need to create a larger array and manually copy all elements to the larger array. And this operation is also very time consuming. Again, if we have million elements, we have to move all elements and create new larger array. And that will take very long time. Then after moving all elements and creating a large array over here, then again, we can move all elements to the right and insert an element in the beginning of this array. Now we understand the logic of inserting new value to the array. Let's see how this is working in Python. Let's switch to Visual Studio Code. Here, I've created an array before in the previous lesson, so I will use the same array because I don't want to waste time to create new array over here. That's why I kept this file like this. So let's see how can we insert an element to the array. I will insert an integer to the first array. For this, we have insert function here. We're just putting dot. Then from the list, if you put insert, you see that there's a insert function over here. So this function takes two parameters. The first parameter is I, and the second parameter is x. I is the index of the element, in which index we want to insert an element, and x is the value of the element. So in this case, for example, let's insert an element at the end of array. So we see that for this array we have 1, 2, 3, 4, 5, 6 elements. It's actually 6 elements over here. We don't need to count them because element starts from 1 to 6. Okay. Then for index we will put here 6 because our index starts from 0. So in this case 6 is the last. Then for element let's put 7. So let me print our array over here again to see that if our element is inserted. I'm just copying it from here and put it here. I will comment this out. Okay, save, and let's clear it. Clear. Oh, sorry. And rerun our code. You see that in the beginning our array is like this, and after insertion we have 7 elements over here. Okay, so in this case we have inserted an element at the end of array. We don't have any problem. Let's see if we can insert an element in the beginning of array. So what will happen in this case? I'll write one more time. I will delete this. Here we know that the first element's index is 0. So if I put 0 here and insert 0 at the beginning and rerun this code, You see, as we explained in the slides, 0 is inserted here, and 1 moved one step right, and 2 moved right one step right again, and this will go like this till the end. So the index of 1 now is 1, not 0. The element that we inserted here is 0, and the index of 0 is 0 in this array. As you see, all elements moved one step right. Let's say if you want to insert an element in the second index. Let's see what will happen in this case. If I put here second and just give one line over here and rerun this code, you see that in the second index, before we had 3. This is 0, this is 1, and this is 2. So in the second index, we had 3. Now we have 9, but 3 is still in the array. It's not deleted because it just moved one step right. So when you insert an element in the middle of array, it works the way that we did in the beginning of the array. The elements just moved one step right. And this is how it works. Let's see the time and space complexity for array insertion. So time complexity differs based on in which part you are inserting the element. If we are inserting an element in the beginning, here we see that we are moving all elements to right, which means that this is time-consuming operation. So this will take O(n) time complexity if we insert an element in the beginning of array. But if we insert an element at the end of array, this is constant time operation because we are just providing the index over here and adding an element at the end of array. So we don't need to move all elements to right or left. It's not taking too much time. That's why inserting an element at the end of array is very fast. But if we insert an element in the middle, it's again O(n) time complexity because we have to move elements to the right, one step to the right. And another operation here, if an array is full and we want to insert an element to this array, this is also O(n) time complexity because we have to create new array and move our elements to this bigger array and insert the element over here. We are not seeing these operations how it's going when we insert the array in the code. These are done by the system automatically, but if you have a lot of elements over here, I'm talking about million or more than millions, then we will have very slow performance over here. So that's all for inserting an element to the array. Hopefully everything is clear now. In the next lecture, we will look at how can we traverse a given array. See you there. All right, in this lecture, we will look at array traversal. So what's a traversing a given array? So traversing means visiting all cells of array over here till the end. There are many different purposes for doing this. It can be printing all elements of array one by one or updating any given elements and so on. So how do we traverse an array? It's very easy. We just need to create a loop and start looping each cell in sequential order. First, it starts from A. Then in the next step, it goes to B and prints out B. And in the next step, it goes to C, next cell, and prints out C. And in the next step, it goes to D and prints out D. And in the next step goes E, then it continues to F. When we reach F, we stop our traversal over here because there is no element over here to traverse. Okay, let's switch to Visual Studio Code and see how traversing of array works in practice. Okay, here I will create new function. Again, I'm using the array that we created in our previous lecture, so I'm not going to delete this. I'll keep it as it is. Then I'll create function over here, which will be traverse array, which will take as a parameter array. And here we will create a loop for I in array. This is the array that comes from the parameter. We will print elements, print I. So this is a simple function which shows how to traverse through array. So if we run this for our array, let me just comment this part that we used in previous lecture for insertion. So here, if we run traverse array for the array that we created over here, I'll put as a parameter array1, arr1, this is to 1. And let's clear here, and let's run this code to see that how this is working. You see it starts from the first element, and then goes to the next element, which is 2, then goes to next element, which is 3, then goes to next element, 4, 5, and 6. It's visiting each all elements of this array and printing them one by one. Okay, this is how traversing works. Let's see what is the time and space complexity of this operation. So if you look at this function that we created in Visual Studio for traversing an array, we can examine this function's time complexity. So the first line of code over here is for loop. We know from our rules that looping through array is on time complexity, and printing the element is constant time operation. So if we combine these two time complexities over here, we can easily see that non-dominant term here is O1, so the time complexity will become On. Space complexity for this method is constant because we don't need an extra location to perform this operation. So in this video, we have learned how to traverse a given array and what's time and space complexity for this. Alright, in this video, we will look at how to access any given cell in the array. So what does it mean to access a given cell in an array? It means that to read the value of given cell number. So how can we tell the computer which particular value we would like to access? This is where index takes a vital role. You can use what's called an index to access a value in an array. This is a number that refers to the location where the value is located. The first element in the array is referred to using index 0. So as you move further to the right, the index increases by 1 for each space in the memory. So as you see, it starts from 0 and it's increasing sequentially until we reach the end. So the general syntax to access an element in an array is like this. The name of array, then the index of cell. For example, if we want to access an element over here, we need to write the syntax like this. Array name and the index, which is equal to A. So if we want to access an element over here, for example, this element, we need to write array name and index 3, and it's going to equal to D. So this is how we are accessing an element in an array. Let's now switch to Python and see how this is working in practice. We need to create simple algorithm for this because there might be some situations that we might try to access an element which is not exist here. For example, if we try to access an element with index of 6 over here, we will see that the system gives us error. So to prevent such cases, we need to write simple algorithm to access an element from the array. Okay, let's switch to Visual Studio Code. Here, from previous lecture, we have an array over here. We have already created this array, so I'm not going to waste time on this. Here, I will create new function, which will be access element. This function will take two parameters. First parameter will be array, which is the array that in which we want to access an element, and the second parameter will be index. This is the index of the element. Here we will write a condition to prevent the cases that if the index is not exist in this array, so we will return a message saying that this index is not exist. So we will write condition like this: if index is greater than length of array, then we will write print something like this. There is not any element in this index. What does this mean? For example, in this case, we have 6 elements in this array. So if we take the length of array, it will return 6. So if we are trying to access an element with the index of 7, the controller will go to this array and will not find it, and this will raise an error. To prevent these kinds of exceptions, we need to write condition like this. So here, else, we will print array element. So how we are going to do this? We'll use print array name. What's the array name? This is coming from the parameter array. Should do like this. Then we will write index over here. So if we are trying to access an element, we are writing array name and index inside brackets. So if you save this and run this function, access element. Okay, as an array, I'll put this array over here, and let's put index 1 over here. Let me clear this. And if I run our function, we see that it returns 2. So what is 2? 2 is the element which is located at the index of 1. So this is 0 and here is 2. So if I try to access an element of 8, for example, with the index 8, let me run this. We see that it returns an error saying that there is not any element in this index. So here, in this function, there's a bug. So if we run our function for the index of 6, you will see that we have different error. You see that Python raised an error saying that array index out of range. This is because length array returns us 6, and we are putting the condition greater than 6. So when it comes to 6, it's giving us this error. So to prevent this case as well, we need to write equal here, because we know that the index starts from the 0. So if we have an array with 6 elements in it, the last index is 5, not 6. So that's why we need to put here equal sign to prevent this case as well. So if I run this function one more time, you will see that it gives us the error that we wrote here. It's not exception that comes from the Python. This is the message that we put here. So in this case, our program will run smoothly without any break. Okay, let's see time and space complexity for this function over here. So if you look at this code carefully and examine it code line by line, we will see that for the first line, this is if condition over here. We know that from our rules that if condition takes constant time complexity, which means that this line of code here will take constant time operation. Then the next line is print statement, and we know that print statement also takes constant time complexity. And in the else statement, we have another print statement over here. We put inside array directly the index. That's why this also takes constant time operation. Because we are not iterating through array, we are just giving the exact address of the element over here, which is the best characteristic of array to access directly to the element based on the index. So this part over here will take constant time operation. So if we combine all these constant time operations, we have constant time operation, which means that time complexity for this method is constant time operation. It is O1. And the space complexity for this function will be O1 also, because we don't need extra space here to perform this operation. So till now, in most cases, we saw that space complexity is order of 1. It does not mean that it will be like this always. As you progress with this course, you will see that there are more complex topics which require space complexity of On or log n or different complexities. For this lecture, we have learned how to access an element of array and what is the time and space complexity of this operation. Now in the next lecture, let's look at how can we search for a given value within an array. Hi there. In this video, we will look at another operation that we can perform on a given array. Here we will search for a given value in the array. This means that we will check if a given value exists in the array or not. Let's say we have an array like this, and we want to know if a value of A exists in this array or not. So how can we find this? To find an element inside the array, we have 3 options. The first option is, if we know the exact location of the element, we can use as index. For example, we know the location of C is index 2, so we can say that this element is located inside this array by accessing it using index. Now the next option is binary search. So for example, if we don't know where the element is located and our data is sorted as like this, you see that in this array elements is sorted. It starts from 1, 2, 3, 4 till 9. We can use binary search over here. Binary search is very time efficient. That's why it's very useful in sorted arrays. I will explain this in upcoming sections. I'm not going to go in detail over here. I was just telling you that there is one more efficient option which is very useful in sorted arrays. Now the next option is we need to search through array by looking at in every element of array like this. So this way of looking is working like this. For example, if you are looking for element of D over here, we will start from the first element. Is this the element that we are looking for? We see that it's no. Then we are continuing to the next element. Is this the element that we are looking for? We see that no. Then we are continuing to the next element. Is this the element that we are looking for? We see that no. Then we are continuing to the next element. Is this the element that we are looking for? We see that yes. So we stop here and printing out saying that, okay, this element exists in this array. So then we terminate here our loop. Otherwise, we return saying that the element does not exist inside this array. Okay, let's see how this is working in practice. Let's switch to Visual Studio Code and write a small algorithm for searching an element inside array. Here I'll just delete this code from here. This is coming from previous lecture. Okay, we have an array like this. So we need to create a function like this. Function will be search in array. This will take two parameters. First parameter will be array, the array that we are going to look inside, and the next parameter will be the value that we are looking for. So the first case here will be we start to loop through array, I in array. So inside loop we will have if condition. If I equals the value that we are looking for, value, this value comes from here, we will return index of this value, which will be array name and index. In this case will be array. This is the array that comes from index value. This function, index function, comes from the array module. Based on the value, it returns the index. So otherwise, over here, we will return saying that the element does not exist in this array. Okay, this is the function that we need for searching inside array. Basically what we have done here, we loop through the array, and in every loop we check that if, for example, first element is equal to the value that we are looking for, then the next element, then next element, until the end of loop. If we find the element that is equals to the value that we are looking, then we are returning the index of that element. Okay, let's check this one for our function. I'll print out this running search in array. As a parameter, I'll put the array that we created over here. Let's look, for example, number 3. For number 3, if I run this, you see that it returns 2. What is this 2? This 2 is the index of 3. It starts from 0, 1, 2. So let's try another example. If I look for 6, it should return 5, which is the index of 6 over here. Okay, let's put one number that does not exist in our array. Let's put 7 and run it. You see that the element does not exist in this array. So our method is working very well, and this small algorithm is useful for searching inside array. Okay, let's see what is the time and space complexity for this method over here. So this is our method. Okay, let's start from the first line. In the first line we have loop. We know that if we loop through array, the time complexity for this loop is O n. Now, you might be interested that if the element that we are looking at this array is located in the beginning of the array, the time complexity should be O1. Why we are putting On here? This is a nice question. So the thing is, when we are looking time complexities, we look in terms of big O. So in terms of big O, this is On, because in the worst case, it will search through all this array, which is the n number of elements of the array. This means that this loop will not take more than On time. It will not be On1 plus b, because n is the number of elements of array, so the loop will stop as soon as the array elements finish. So the time complexity for this will be On. Then we continue to next line of code. Here we have if condition, and we know that if condition is constant time operation. Then we continue over here. So that this is the standard function from the array model. It's just bringing the index of given value, which is a direct. So this is constant time operation. Over here, constant time operation. And return value, just returning the element does not exist in the array, is also constant time operation. So if we combine all of these, we know that here dominant term is On and non-dominant terms are 3 O1s. So which means that the time complexity for this method will be On. So if you look at the space complexity, we see that to perform these operations, we don't need extra space over here, which means that for this method, space complexity will be O1. Now, hopefully everything is clear now. You have understood how we can search for a given value inside an array. So in the next video, let's look at how to delete an element from the array. Okay, see you over there. All right, in this video, we will look at how to delete an element from the array. Let's say we want to delete an element of B from this array. So to maintain the efficiency of random access, the elements must be stored in contiguous space of memory in the array. So you cannot just delete this array from here and leave this space empty. So this is not allowed here, because in this case, we are losing the efficiency of accessing an elements of the array with using index. You know that one of the advantages of the array is accessing its element by using index, which is very fast. So to leave an element empty over here will violate this characteristic of array. Okay, how can we delete the second element then? So the answer is we should move all elements here after deleting it, and it's going to be like this. This means that when we delete an element of B from this array, the next element, which is C, will move to the place of B, and D will move to the place of C, and E will move to the place of D, and H will move to the place of E. Then the last cell will be empty. So before C's index was 2, now C's index is 1. So in this way, B is successfully deleted, and the efficiency of array is kept. Please note that deletion is very efficient when you remove the last element. Otherwise, deletion becomes time consuming. So let's switch to Visual Studio Code and see how this is working. Here, this is the array that we created before. Okay, to remove an element from the array, we just need to connect the array's remove function and provide the value of element over here. For example, if you provide 1 and save, let me print out this array after this removal. So let's run our code. We see that the element of 1 is removed and the element of 2 moved to its place, and 3 moved to 2's place, and it goes like this. So if you want to remove, for example, the last element, let's provide here 6 and run it. You see that 6 is removed from the last part of the array. Okay, let's try one more example which will remove the element from the middle of array. Let's see what will happen in this case. If I put here, for example, 4 and save it and run our function one more time, you see that 4 is removed and 5 is moved to the place of 4 and 6 is moved to the place of 5. And this is how removal works. And let's see what is the time and space complexity for this remove function. So the time complexity will vary for this remove function. As we said before, if we remove the last element from the array, the time complexity will be O1 because we are just directly connecting to this element and removing it. But if we remove element, for example, this element, the time complexity will be On because after removing of this element, we need to move all these elements one step to left. So in worst case, which will take On time complexity. And in this case, we don't need extra space for performing this operation, so the time complexity will be O1. And hopefully, everything is clear now for the deletions. So in this video, we looked at how we can delete an element from the array, and we saw the time and space complexity for it. See you in the next video. Hi there. Till this lecture, we have learned what's an array, how it is represented in memory, and we performed some operations on a single-dimensional array. Now in this lecture, let's see time and space complexity of operations that we performed. So the first operation is creating an empty array. Creating an empty array takes constant time complexity, and space complexity will be On. Because when you create an empty array, you have to specify the size of array. So which means that if the size of array is n, space complexity will be On. This is because the system has to allocate n cells for this given array. Then the next operation is inserting a value in an array. So if we are inserting a value at the end of array, it will take constant time complexity. But if we insert a value in the beginning of array, it will take On time complexity. This is because that when you insert a value beginning of the array, all elements has to shift one element to right. So this will take On time complexity. Imagine that if we have million elements in one array, so if we insert an element in the beginning of array, these million elements has to shift one element right. So this will take On time complexity. But here, space complexity is O1 because we are just allocating one extra memory for this. So for this process, we don't need extra space. Then the next operation is traversing a given array. So traversing a given array will take On time complexity because what traversing means is that we have to visit each element of an array and we can print it or update it. So this means that we will visit whole array's elements. So this will take On time complexity. Once again, space complexity here is O1 because we don't need extra space for performing this operation. Then the next operation is accessing a given element. So accessing a given element of array takes a one-time complexity, because in this way arrays is the most efficient data structure, because by using their index we can identify the address of given cell and directly can access to this cell without looping or searching for this given cell. And the space complexity, one more time, for accessing a given cell will be constant time complexity, because here again we don't need any extra space to perform this operation. Then it comes searching a given value. Searching a given value inside an array will take O n time complexity, because we need to visit each of cell and see that if this is the value that we are looking for or not. We can find our element in the beginning of array, but this does not mean that it will be O1, because in this case we are taking time complexity in terms of big O, and big O takes the worst cases. This means that searching a given value will not be more than O n. So the space complexity for searching a given value, again, constant, because we don't need extra space for searching a given value. Now let's continue to next operation. The next operation is deleting a value from an array. Okay, if we are deleting a value from the end of array, then this is fine, because we don't need to loop through array. We are just going to the last element and deleting it. So the time complexity here will be constant time complexity. But if we are deleting an element from the middle or beginning of the array, then this will take O n time complexity, because when you delete an element from the beginning of array, each element in the array has to shift left. So imagine that if we have billions of elements in the array, this means that all elements have to shift one step left, and this is time consuming process which will take O n time complexity. And for this one also we don't need any extra space, that's why space complexity is constant. So hopefully everything is clear now. Actually, we explained these operations before in previous lectures, and I've talked about their time complexity and space complexity. Here just I combined everything together and to show you a big picture of time complexity and space complexity of one-dimensional arrays. So this is all for this lecture. So in the next lecture, let's do practice on arrays. Hi there. So far, we have learned different properties of arrays and performed different operations on arrays. Now in this video, I'll put everything together to have a big picture of arrays, and additionally, we will get familiar with built-in functions of arrays in Python. So here, we will perform 16 different operations. As you see, I have put all of them here to make our lives easier. So we will perform these steps one by one. So let's get started. So we know that to use arrays in Python language, we need to import array module. So in the beginning, I will import array module from array import star. This line of code imports array to our project. Star means that we are importing everything. Once we imported array module, so we can continue to our first step. So what's first step? First step is we create an array and we will traverse through array. So let me just put like this, because I want to make these comments as header for each step. So we'll start from here. So let's create one sample array. So when we create an array, first we need to write array's name. So array name will be like this, my array equals. Let's create an array of integers. So to create an array of integers, we need to put first array keyword here, which is coming from array module. And then we need to provide data type. Data type is the type code. As you remember in lecture where we explained how to create an array in Python, I gave the list of type codes. So I'm not going to provide it here. If you want any data type, you can go back and see in this lecture. By the way, I will include in the resource section of this lecture the type codes that are available for recent version of Python. So here we will create integer, so which means that I'll put as a code here I. Then we need to provide the list of elements. So here I will put 1, 2, 3, 4, 5. So we have 5 elements in this array. So with this, we have created our array. This type code over here, I, represents a signed integer whose size is 2 bytes. So the next operation inside this step, we will traverse through array. So how we are traversing through array? We'll just create simple loop in my array and print out array elements. Print array elements. Okay. Hi. Let's run our code to see that everything is working smoothly. Okay, if I run this, Python 3, so array practice is going to be array practice. have two files here. So it's going to be array practice. You see that when I run this code, it's traversing through all elements and printing out them one by one. So first it goes to first element, then printing out first, then it goes to second element, printing out second, and third and fourth and fifth. So for the first step, everything works smoothly. And I just want to remind you that the time complexity for this operation is O (n), because we are traversing through all elements of this array. Okay, we are done with our first step. Let's continue to our second step. So what's second step? Second step is accessing individual elements through indexes. So we know that individual elements of array can be accessed through indexes. An index of arrays starts from 0. So for example, let's access first element of this array. So how we are going to do this? So to access first element, we will use index 0 because we know that index starts from 0 in arrays. To do so, we need to first write array name. Then inside brackets, we will write index. So let me print out this. Print. So to identify the step 3, I'll put one more print over here to see that this is coming from step 2. Step 2. So let me save it and let's clear this part. Let's run our code again. We see that in the step 2, we have accessed our first element, which is 1. So we print it out from here using print statement. So to access any given element in the array, we are using indexes. So let's try one more example. Let's change this one to, for example, index 3 and run our code. We see that in step 2, we have 4 here. So the index of 4 is 3 because it starts from 0, 1, 2, 3. So with this, we know that to access an element of an array, we are using index. Okay, let's continue to the next step. In the next step, we will add an element to the array using append method. So we have different methods of inserting an element to the array. In this case, we are using append method. By using append method, we can only insert an element at the end of array. Let me just copy this from here and put it here as a step 3. To access append method, we just need to write array name dot append. So here we can put the value that we want. You see that it says that append new value to the end of array. So this function appends an array and adds new element end of the array. You cannot use this method to add an element in the beginning or in the middle of an array. So let's put, for example, after 5, 6 here. And then let's print out our array, my array, and run our code. You see that after step 3, our array comes here. We print out our array. So we have an extra element of 6 at the end of array. Before we had 5 elements, now we have 6 elements. As we said before, if we are adding an element at the end of array, the time complexity for this operation is O(1). So by using append function, we can add an element at the end of array very fastly. So let's continue to the next step. The next step is insert value in an array using insert method. So this is different case. Here, by using insert method, we can add an element at any point of our array. But this will be time-consuming process. So let's see how this is working. Okay, once again, to connect this method, we need to write array name. But before doing so, I'll just copy this and put it here and make it step 4. Then I'll write array name, then insert. Here, it takes 2 parameters. First, we need to put the index where we want to insert the element. Then we will put the value of element. As you see, when we select insert, it shows that insert a new item into the array before position I. So if I put I as 0 and element, for example, 1, 1, and run our code, but before running, let me just print out to see the result, my array. So let's run our code. We see that after step 4, our array is printed. So the first element in the array now is 11, which means that when you use insert function, and if you put 0 as a parameter, it's going to insert in the first element. As we said before, this is a very time-consuming process because when you add in the beginning of array a new element, the other elements have to shift one step right, and this is a very time-consuming process. We can use this insert function to add an element in the middle of array. Let's put 3 here and run our code again. So 11 is added before index 3. It takes the place of index 3. So let's continue to the next step. In the next step, we will use extend method to extend our array. So what does it mean? By using extend method, an array can be extended with more than one value. So here, as you remember, by using append function over here, we just appended our array with one element. But here we can create another array, and using extend method, we can extend our array with this array, newly created array. Okay, let's create one new array over here. My array, I will put 1. Then it's going to be type of integer again. So I, and let's create elements from starting from 10, 11, 12. So by using extend method, we can extend our previous array with this array. So to use it, we need to put array name dot extend, and as a parameter, we will put this array over here. Okay, like this. Then if we print out our array, we'll see the result. Let me just print this array because the array that we are going to extend is this one. And let me put here step 5 to identify the steps. Okay, step 5. Now let's run our code. This is step 5. We see that, so our previous array was this till 6 because here we added 11 to our array. So it starts from 1, 2, 3, 11, 4, 5, 6. Then we have new array over here which has 3 elements. By using extend function, we put these 3 elements at the end of this array. So the last 3 elements is the elements that come from this array. So hopefully everything is clear for this. So let's continue to our next step. In the next step, we will use different function from this function. This function also adds elements to our array, but the only difference is it adds error from the list. As I told you before, arrays is not built-in function in Python. Instead of array, they have list over here. In the next section, we will talk about list, but here you just need to know that it's kind of same data type as arrays. So let's just, for simplicity, create one simple list over here. The creation of list is like this. Let me just put temp list equals, you just need to provide elements. I'll put here 20, 21, 22. So then if you want to add this list to this array, we just need to put my array dot from list, and as a parameter we just need to provide this list over here. One more time, let me copy these steps from here and put it here, and this one also. I'll change the step number to 6. And let's save this and let's rerun our function. You see that in the step 6 we have the array that we had before. This is the array that we had before. So we added extra 3 elements at the end of this array. But in this case, these elements come from list data type. So it's not coming from the array data type. Yes, as you see, it's similar to array data structure, but there are a little bit differences. I don't want to give more detailed information about this in these sections. We will do it in the next section. Okay, let's continue to the next step. The next step is remove any array element using remove method. Actually, we saw this process in the previous lecture, so I'm not going to waste a lot of time on this. I'll just copy this code from here and put it here and just delete this part. 7. So here we just need to call remove function. Okay, let's just remove one element. Okay, if you want to remove the last element of this array, which is 22, so let's run our function. You see that 22 is removed from the last of element. You can put any element over here. For example, let's delete 11. As you see, 11 is repetitive in this array. So the question is, if we run this function, what will happen? Is it going to delete all 11s or it's going to delete only one? Let's see what will happen. If I run this function, you see that we have 11 over here, but the 11 over here is removed, which means that a remove function works like this. When it finds the first occurrence of this value in the array, then it removes it and that's it. It's not continuing to find another occurrence of this array. So this is how remove function works. So as you see, this is very time consuming. Here also we have n time complexity because it has to remove one element from the array and move all elements to the left. Okay, let's continue to the next step. Next step is remove last element by using pop method. So as we said before, removing last element is very time efficient process because we don't need to move any element to right or to left. So to do so, we can use pop method, which is built-in function in array model. So let's run this function and see how this is working. If I run this like this, and as you see, in this case, our last element is 22. So if I run this, so in the step 7, we have this array. As you see that if we run pop function, we remove the last element from the array, and which is very time efficient process. Now let's continue to step 9, in which we will use index method to find index of any given element. So here, I will just print out the value. So once again, we'll write array name, my array dot index method. Here, for example, if I provide the value of 21, let's see what's the result. So in step 9, we have result of 10, which means that this is the index of 21 in our array. Okay, let's see if this is correct. It starts from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you see, the index of element of 21 is 9. So this method returns the index of any given value. So that's it for this step. Let's continue to the next step, in which we will use reverse method to reverse our array. So one more time, we will write our array name, which is my array dot reverse function. So here we will not provide any parameter. So if I just one more time print our array, we will see the differences. Here is it, step 10. Okay, let's run our code. You see that in the step 8, we have our array over here, and in the step 10, this array is reversed. So the last element comes to the first element, then the element from before the last element comes to the second element, and it continues like this. Our first element now is the last element. So by using reverse function of an array, we can reverse elements of any given array. So let's continue to the next step, which is 11. So here we'll use buffer info method. These methods provides you the array buffer start address in the memory and the number of elements in the array. Okay, let's see how this is working. I'll just copy this code again one more time. It's step 11. Here we will put buffer info with no parameter. So let's print out this information, because otherwise we will not see it. If I run our code, you see that it says that our array buffer starts from this point in the memory, and it has 11 elements. If we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 elements. So this function can be used to get information on our array. So let's continue to the next step. So the next step is count method. So in many programming languages, when you use count method for array, it counts all elements of the array. But in Python, it works different. Here, it counts the occurrence of that element. How many times this element occurred in the list. So let's see how this is working. So if I'll just print again this one here. Let's run this. Count, for example, I'll count element of, for example, 11. Now we don't have repetitive element over here. It should return 1. You see that it returns 1. But before doing that, let me add another element over here. Let's use append method. I'll add 11 at the end, one more time. And if I run this function, it should return 2. This returns error now because I did something wrong here. Array name is my array. So if I run this, you see that now it returns 2, which means that the occurrence of 11 in the array is 2. So we can easily see by printing out this array. I'll just print out this my array to see that everything is correct. So if you look at this array, you see that 11 is here, and at the end we have one more 11. So by using count function, we can count the occurrence of elements in the array. So many people mix this with the count of elements. I want to make sure that this is not the count of all elements, it's just the occurrence of elements in the array. So let's continue to our next step. Now the next step is converting array to string using toString method. Now if we try to convert our integer array to string, you'll see that we have strange characters. But it doesn't mean that it's not working properly. So let's try it. For now, we'll create one temporary array, string str temp, and then I will assign this array the string format of our integer array, which is my array dot to string. And if I print this out, you'll see that we have some strange characters over there. Okay, let's save it and let's run it. You see that it print out in step 13 strange characters. So how do we know that this is working properly? So if we convert this back to the integer, we'll see that our array works properly. So let me create another array which is empty integer array. It's going to be like this, array integer, and here I can do like this. From string, calling from string, we can create an array of integers from string. Then I will put this array over here. Now if I print out this array, you'll see that it's going to be the same array that we had before. Sorry. Okay, let's run our code one more time. Then when we convert that string to this integer array, it is the same as with array that we have before. So this is how toString method is working. So the next step is we will convert our array to list. So to do so, we just need to call toList function. Here it's going to be like this. Let me just print out the result of this toList function. List. So let's see what is the difference. Okay, as you see, we converted our array to the list. So when we print out our array, it shows that array is type of integer and it's going and printing then the elements. But when you print out the list, it's coming like this without showing the data type of list. It's just printing the elements. So this is how we can convert our array to the list. So let's continue to the next method. Here I will just comment out this. I don't need to convert it to list because here we are talking about arrays. So the next method is append a string to the char array using from string method. So as you see, we used here this method, so it's going to be the same operation as we did here. So I'm not going to do anything here. We can just combine these two steps over here. So I use this from string method to show you that our toString method works properly, because otherwise it's not possible to see it, because when we print out, we see the strange characters over here. So I'll skip this step over here. Then we will continue to step 16. This part is very interesting because here you can just slice the arrays into the parts. So how this is working? Let's see how this is working. For example, if you want to print out only first three elements of the array, you can slice it by using this slice functionality of array. So how this is working? You just need to write the array name and the indexes that you want to print. So if I put from 1 to 4, it will print 3 elements because it's always printing the element till the element, this last index that we provide here, -1. If I print out this information, you'll understand it very, very well. Okay, let's run this. You see that this is our array over here, and by using this slice functionality, we can just print out first 3 elements of array. But here we just need to put 4. Every time if you want to print out 3 elements, you have to add 1 and put it here. If you want to print out 4 elements, you have to put 5 here. There are some other different ways of expressing slicing. So if I put here empty and here 2, it will start from the second index, printing out all elements. So if I run this, you see that this is 0 index, this is first index, and it starts from the second index. So if I leave this one empty and put, for example, 4 here, let's see what will happen. In this case, it prints all elements till the 4th index, but 4th index is not included here. As I said before, this part is -1. Let's see what happens if I remove this one also and put it like this. If I print out this function, you see that it's just printing all elements, so without any slicing. So slicing might be very beneficial in many situations because this functionality provides more flexibility in many cases. So with this step, we come to the end of our lecture. Hopefully you have understand all steps over here, and hopefully you get deep knowledge about built-in functions of array in Python. Alright, now in the previous lectures, we have learned how to create a one-dimensional array and perform different operations on it. From this lecture, we will look at two-dimensional arrays. So before diving deep into the operations, let's review one more time what's a two-dimensional array. To understand it better, we can visualize a two-dimensional array like this. As you can see from this picture that two-dimensional array is a combination of one-dimensional arrays. Here we have 3 rows, which means that the first row is first one-dimensional array, the second row is second one-dimensional array, and the third row is third one-dimensional array. Here you can see that in one-dimensional array, we have only one row and multiple columns. But in two-dimensional array, we have multiple columns and multiple rows. So in this case, as I mentioned, this is a combination of 3 one-dimensional array over here. So you might be interested, why do we need a two-dimensional array? In which situation we will use a two-dimensional array? The answer is, when you deal with matrix, then you have to use two-dimensional arrays. For example, many games use two-dimensional arrays to plot visual environment of game. Let's look at another example. Consider a station of recording temperatures 4 times a day every day. So we are doing it for 4 days. So for each day we are recording temperatures 4 times a day and keeping it like this. So how can we present this data in an array? So we cannot do it in a one-dimensional array because as you see we have columns and rows over here. So for such situations, two-dimensional array is very useful. In terms of two-dimensional arrays, you have to be very careful that we have 2 brackets when we access the elements. But in terms of one-dimensional array, we have here only 1 bracket. Here the first bracket shows the row number and the second bracket denotes the column number. So let's say if we want to access a value over here, this is row 0 and column 1. So we need to write A01 to access this value over here. We have discussed this in our previous lectures, so I'm not going to go in details. So now we know what a two-dimensional array is and what it looks like. So let's continue to create a two-dimensional array. So as we said before, there are 3 steps for creating an array, and this is applicable for two-dimensional array as well. Here we need to create a variable and assign the array to it, which will be the name of array. Then we define the type of elements. Then we define the size. As we said before, this third step might not be needed in some programming language. And we can easily combine these 3 steps in one step and writing it in one line of code. So let's see how this is working in practice using Python programming language. So here I will use the example that we gave before related to daily temperatures. So that's why I copied the information from the slides over here, which is the daily records of daily temperature. So here, instead of array module, we will use NumPy module because this module works perfectly with multi-dimensional arrays on Python. So to use it, we need to first import it. So we will import it like this, import NumPy as NP. Then we can create our array like this. Two-dimensional array equals np.array. I need to put here np array. Here I will copy the code from here. So to make our life easier, I'll do like this. Let me just open 2 brackets here. So first row will be inside this bracket. Let me copy this from here to here. Then the next row again inside this bracket. I'll copy it from here to here. Then the third row, we need to copy it from here to here. Then fourth row will be over here. So this is the way we are creating our two-dimensional array using NumPy module. So if you look at here very carefully, you can easily see that first we are opening 2 brackets over here. Then inside these 2 brackets, we are putting our rows one by one. So we have over here 4 rows. So here you see that the first row is this one, and the second row is this one, and the third row is this one, and the fourth row is this one. So if we print out this two-dimensional array, we will see how it looks like. So let me print it, two-dimensional array. So let's run our code. You see that it's printed like matrix here. So from this output, you can easily see that this is our first row, this is the second row, this is third, and this is fourth. From here, this is first column, and this is second column, third column, and fourth column. So from this picture, you can easily see that how two-dimensional array looks like in Python. From here, you can easily see that if we take only this part, it is one-dimensional array. and we have another one-dimensional array over here, then continues till the end. So this is how we are creating a two-dimensional array using NumPy model in Python. So what is the time complexity of creating two-dimensional array? If you are doing it like this, the time complexity will be O1, which is constant time operation, because we are not creating array separately and assigning values one by one. We are just creating and assigning values, all of them together. So this operation takes O1 time complexity. If we create empty array, then assign values one by one, it will be OMN, where M is the number of columns and N is the number of rows. So this is very time consuming operation. That's why it's very advisable to create a two-dimensional array like this. We are initializing the values straight away. So the space complexity for this operation is OMN because we have M number of columns and N number of rows. So we need this number of space in the memory. So this is all for this lecture. Here we have learned in which situation we can use two-dimensional arrays and how can we declare it in Python very easily. Now in the next lecture, let's look at different operations that we can perform on two-dimensional arrays. See you over there. Okay, now in the previous video, we have learned how to create a two-dimensional array. Now in this lecture, let's look at inserting a new value to the two-dimensional array. Now insertion over here is different than one-dimensional array because here we cannot insert a single value and we need to insert a row or column. Let's imagine that we have an array of two dimensions like this. So if we want to insert an element over here, so what will be the values for the next rows here? We cannot leave the rest of rows empty because then it's not going to be two-dimensional array. The system will recognize this array separately as one-dimensional array like this. The format of a two-dimensional array must be in matrix format. So how can we add new value to the two-dimensional array? There are two different ways of adding elements in two-dimensional array. The first one is addition of columns and the second one is addition of rows. Let's look at how can we insert a column at the beginning of two-dimensional array. So imagine that we want to add this column to this two-dimensional array in the beginning of two-dimensional array. So what will happen? So in this case, when we add this column over here, so the columns in two-dimensional array has to move one step right. Otherwise, we cannot insert this column over here in the first column. So this is going to be like this. So it's going to be added in the zero index. So all rest columns will be moved one step right. So as you see, this is very time consuming operation because every time when we add a column in the beginning of two-dimensional array or in the middle of two-dimensional array, the next columns have to move one step right. So every time this will take so much time. Imagine that we have million rows or columns, and to insert in the beginning of the two-dimensional array will be very time consuming. That's why the time complexity of this operation will be OMN, where M is the number of columns and N is the number of rows. So each time we are moving N number of elements one step right till we reach M. So let's see how can we add new row to two-dimensional array. Imagine that we want to add this row to this two-dimensional array in the beginning of this two-dimensional array, which will be here in the zero index. So what will happen in this case? When we add this row over here, so each row will move one step down. It's going to be like this. Then this row will be added over here, like this. So as you see that the first row from the two-dimensional array moved one step down and became the second row, and then the second row moved one step down, became the third row. So this is also very time-consuming operation. Every time we have to move rows down. So the time complexity for this operation also will be OMN, because so every time we have to move these rows, in the row there might be m number of elements, so we have to move these n number of times. So the time complexity will be OMN. Now we understand the logic of inserting a new row or new column to two-dimensional array. Let's see how this is working in Python. So let's switch to Visual Studio Code. So here we will use insert function of arrays to insert a new row or column to our two-dimensional array. As you see, we have already created this array before, so I kept it not to waste some time on this. So here I'll create a new array, new two-dimensional array, the array, and I will assign this array the previous array with new columns or rows. So we will use insert functionality of np. So np.insert. It will take as a first parameter our array in which we want to add any row or column. So here I will put to the array. Then in which position we want to add. As we said, we are going to add in the first row or column. So in this case, it's going to be column. Then what we want to add, we need to provide here the elements. So from here, we know that how we are going to express columns or rows. So it's going to be like this. Inside two double brackets, I will put 1, 2, 3, 4. We have 4 elements over here, so here we must have 4 elements. And then we have to decide where we are adding these elements, as a column or as row. So we have, for this we have axis parameter over here. If we set it 1, then it's going to add column. If we set it 0, then it's going to add row. So in this case, we are adding column to this array over here. So I'm going to print out this new array to see the differences between the previous array and the newly created array. So let me just copy it here, and let's run our code. So if we run our code, we see that the elements that we provided here are added as new column to our array. This is the previous version of our array. We have first column here like this, 11, 10, 12, and 15. But in this case, the first column moved one step right, and the column that we added is added over here as a first column. So the rest columns also, each of them moved one step right. So that's why I said before that this is very time-consuming operation. Okay, let's continue to add new row over here. So if I just change this value to 0 and rerun our code, you will see that this element is added as a new row. So as you see, now we have these elements over here added as new row. So this 0 means that we are adding to the first row. So here again, before the first row was this, 11, 15, 10, 6. Now it moved one step down, and the first row is now like this. So each of rows has moved one step down. This is also a very time-consuming operation. So for example, if we want to add this row, not add in the first row, we want to add in the second, we just need to change the index over here and save it and run it. You will see that it's added in the second position. So here, the first row was like this, and it stays like it, as it is. But the second row moved one step down, and this newly added row is added over here. So by changing this index over here, we can add anywhere the row that we want to add. And additionally, we have another function which is adding row or column at the end of two-dimensional array directly. So let me just copy this code over here and try with that. Here, instead of insert, we will use append function. So it's going to be kind of same, append. We'll use again array, and without index, we will just provide this value over here. Let me just copy it from here and put it here. And we just need to provide access. If I provide 0, it means that we want to add new row. So let me just comment out here and rerun this. You see that new row is added at the end of this array. So by using append function, we can add row or column at the end of two-dimensional array. So the time complexity for this operation, as we said before, is going to be OMN, where n is the number of columns and n is the number of elements. But when we add column or row at the end of two-dimensional array, in this case, time complexity will be O1, because in this case, we don't need to move any row or columns one step down or one step right. That's why the time complexity for adding new column or new row at the end of two-dimensional array is very efficient. So that's it for this lecture. On the next lecture, let's see how can we access elements of two-dimensional array. See you there.
Hi there. In this video, we will look at how to access any given cell in two-dimensional array. We know that accessing a given cell means to read the value of a given cell number. As we learned in one-dimensional array, we access elements of the array using its index. Here, in two-dimensional array, the index takes a vital role. In one-dimensional array, we have one index which starts from 0 and get increased sequentially, which represent the columns over here. As you see, we have the column 1, 2, 3, 4, and it continues like this. And the index starts from 0. But here in two-dimensional array, we have two indexes. The first one represents the rows, the first row, second row, and third row. Here also index starts from 0, and the second index represents columns. This is first column, and this is second column, and this is third column, and it continues like this. So to access any given element in two-dimensional array, the syntax is like this. So here, the first index is I, which represents row index, and the second index, which is J, which represents column index. So for example, if I want to access an element over here, first we need to find out row index, which is, as you see, it's 0, and then we will find out column index, which is 4. So to access this element over here, we need to write something like this. So here 0 is the row index and 4 is the column index, and A is the name of array. Let's see another example. Let's say we want to access an element over here. Here, once again, we need to identify row index, which is 2 in this case, and then column index, which is 5 in this case. So to access the element over here, we need to write something like this, which is first row index and the second is column index, and A is the name of array. So this is how we are accessing an element in two-dimensional array. Let's see how this is working in practice. One more time, let's switch to Visual Studio Code and see how this is working over there. So here we have our array like this. So we need to create a function which will access the elements of this array. So let's create a function. We'll create a new function like this. If access elements. And this function will take an array as a parameter, then row index, then column index. Then first we need to check if this element exists in this array or not. If not, we will print out a message, otherwise we will continue to access it. Because if we don't do this, then Python will raise an exception and will stop our program to run. So here we will write like this: if row index is greater and equal to length of array. Now in this case, if we just take the length of array in two-dimensional array, it returns number of rows. To return the number of columns, we just need to provide 0 index over here. You will see it now. And another condition will be column index should be greater and equal to length of array in 0 index. And this is returning the number of columns. And without this index, if you write just array, it returns number of rows. Please take into account that this is very useful. So if row index is greater and equal to number of rows and column index is greater and equal to number of columns, then we will raise error saying that print incorrect index. Why we are putting equal here? Because the index starts from 0. So if you have, for example, 5 rows in the array, the last index will be 4. So 5 should be included over here. Else, we will access the element of array. So array, so first index is row index, and the second index is column index. So let's print out this and save it. So let's run our code. I will put this function over here. Here, as a parameter, it will take this array. And let's provide as an index 1, 2. So this is row index, this is column index. Let's see what will give us. So this is our array, two-dimensional array. So to access row 1 and column 2, it should be something like this. We start from here, this is 0, this is 1. And the column starts from here, this is 0, 1, 2. The value should be 11. As you see, we have 11 over here. Let's try one more example. If I put here, for example, 2 and 3, let's run it. You see that row index is 2, so 0, 1, 2 should be over here, and column index is 3, 0, 1, 2, 3, so it should be 8. So the answer, as you see, that it prints out 8. So our function is working very well, and this is how we are accessing an element of two-dimensional array. Take into account that this condition is a must, because otherwise our function will raise an exception from Python. Now we know how can we access an element of two-dimensional array. Let's see time and space complexity of this method over here. So one more time, we have to start from the first line. This line of code over here is just if condition, which is checking the number of rows and number of columns in two-dimensional array. So the time complexity for this will be O1. Then the next line of code, which is printing the message saying that this is incorrect index. This is also constant time operation, which will be O1 again. Then in else condition, we have print statement here, which is printing the value of a cell in two-dimensional array. And we know that arrays are very useful when we access their elements using their index. So this is very efficient. So the time complexity for this will be O1. So if we combine this 3 time complexity, we will receive O1 time complexity. So accessing an element of two-dimensional array takes O1 time complexity, which is constant time complexity. So let's look at what's space complexity for this. The space complexity is again O1. As you see, we don't need any extra space here to perform this operation over here. Calling this function will not take any extra space in the memory. So that's all for this lecture. We have learned how to access an element of two-dimensional array and what is time and space complexity of this operation. Now in the next video, let's look at how to traverse a given two-dimensional array. Okay, see you over there. Alright, in this lecture we will look at array traversal in two-dimensional arrays. We know from our previous lectures that traversing means visiting all cells of this array over here. So there are many different purposes for doing this. It can be printing all elements of an array one by one or updating any given element or so on. So the question is, how do we traverse a two-dimensional array? It is different than one-dimensional array because here we need to traverse through rows and columns. So the traversal in two-dimensional array works like this. We start from here, which is first row and first column. Then we are printing out this value over here. Then we are continuing along this row. The second element in traversal will be 33, which is 0 row, 1 column. Then the next will be this one, which is again in the first row and third column. Then it will continue again in first row and fourth column. As you see, when you traverse through two-dimensional array, you have to first finish first row, then continue to the next row. It works like this. Then we are continuing in the next row until we finish all columns over here. If you think of these rows as one-dimensional arrays, we can easily see that there are 3 one-dimensional arrays over here. So which means that we have to traverse these one-dimensional arrays one by one. So the first one will be like this, then the second one, then it goes to the third one. And in each visit, we are printing out the element's value. So it will continue like this. So this is how the traversal works in two-dimensional array. Hopefully, you now understand how this is working. I just tried to show you here visualization of the traversal. So now let's switch to Visual Studio Code and see how traversing an array works in practice. Okay, here, let's see how can we traverse two-dimensional array. So for this one, we will create again one new function. Function will be traverse to the array. So this function will take an array as a parameter, which will be two-dimensional array. So here, as I showed you before, first we will traverse through rows. So that's why I need to create a loop here for row for I in range length of rows. So you know how to take the length of row from the previous lecture. We discussed that if we take the length of array, it returns the number of rows. But if you put index 0 here, it returns number of columns. Then we will write another for inside this loop because for each row we have to visit all columns. So here we need to take the range of columns. Array is going to be in 0 index. So in this way we can count the number of columns in the array. So for each element we will print out the value of elements. First we will select the row, then the second it will be columns. So for each row we are traversing through all columns. So let's run this function for this array that we created before to see that everything works correct. Okay, traverse array, then as a function I'll put two-dimensional array from here. Okay, save it. Let's run our function. I'll just make it this bigger to see it everything clearly.
So let's run it. Okay, we have syntax error here because I forget to put this 0 inside brackets. Should be like this. If I save it, let me clear it, then I will run our function. Clear. So let's run it. This is our array over here. As you see, this is two-dimensional array. So how we are traversing? First, we are going to the first row and first column. Then we are going to the second column, first row. Then we are going to, in the first row, the third column and fourth column. As you see, it's printing 11, then 15, then 10, then 6. Then it continues to the second row. It's going to print this row over here. As you see, it's printing 10, 14, 11, and 5. Then it continues to the next row here. It's printing 12, 17, 12, and 8. And it continues like this. As you see, traversing through two-dimensional array is different than traversing in one-dimensional array. In one-dimensional array, we have one loop over here, but in two-dimensional array, we have two loops over here. So let's see what's time and space complexity for traversing two-dimensional array. So we know that if we have nested loops in a function, so the time complexity is quadratic time complexity. But here, if the number of rows equals to the number of columns, then we have quadratic time complexity. Otherwise, we will have OMN, which will be the m will be the number of columns and n will be the number of rows. So if you look at this function, let's start from here, print statement. We know that print statement takes constant time complexity. So this will be the constant time complexity. So the loop here, inside loop, will be ON time complexity, which will be the number of columns. N is the number of columns. Then the time complexity for outside loop will be OMN, because for each row, we have to traverse through all columns. So which means that if the number of rows is m and the number of columns is n, so the time complexity will be mn. If m equals to n, then the time complexity will be quadratic time complexity. And let's see space complexity. The space complexity is O1 because we don't need any extra space for performing this operation over here. And that's it for traversing two-dimensional array. Hopefully everything is clear now. And in the next video, let's see how can we search for a given value inside two-dimensional array. See you there. Hi there. In this video, we will look at another operation that we can perform on a given two-dimensional array. Here, we will search for a given value in two-dimensional array. This means that we will check if a given value exists in the array or not. Let's say we have an array like this, and we are looking for a value of 44 inside this array, whether it exists here or not. So how we are going to do this? There are many algorithms available for searching two-dimensional arrays, but here we will look at linear search. In linear search, we need to search through every element in the array and check if the current element is the element that we are looking for. It continues like this until we find the element that we are looking for. Let's say we want to look for 44. So how linear search works? It starts from the first element. It checks that if this is the element that we are looking for. Is this the element that we are looking for? We see that no. Then it continues to the next cell. Is this the element that we are looking for? We see that it's not equal to 44. Then it continues to the next element. Here we see that this is not the element that we are looking for. Then it continues to the next element. Is this the element that we are looking for? We see that no. So after this, it continues to the second row. And in the second row, it starts from the first column. Is this the element that we are looking for? No. Then it continues to the next one. Is this the element that we are looking for? No. Then it continues to this one. Here we see that this is the element that we are looking for. So the loop will start here. So basically, finding an element using linear search is just checking every single element of array to see that if this is the element that we are looking for or not. Of course, there are many other efficient ways of searching a two-dimensional array, but I'm not going to in detail here because these are belong to other lectures which will be explained in upcoming lectures. So let's see how this is working in practice. One more time, let's switch to Python. So here we will create a function which will search in two-dimensional array. So this is the array that we created before. So by using a search function that we are going to create here, we will search inside this two-dimensional array. So I'll create a new function called search in two-dimensional array. Search to the array. Then this function will take as a parameter an array, the array in which we are going to search, and the element that we are looking for. I'll put here value. So as we said, we are going to look for an element
using linear search. So for linear search, we have to visit each element of this two-dimensional array. So for this, I will start like this. For I in range len array, I'm starting from the rows. This is returning the number of rows. So then for each row, I will visit each column. J in range length array. You remember I told you that if we put index here 0, this means that this will return the number of columns. Then here I will check if this value is equal to value that we are looking for. If array I and the column will be j equals the value that we are looking for, then I will return something like this. The value is located at index. Let's print the index. Need to convert this to string. I, let's put like this, str j. Otherwise, if we cannot find the index, we need to return something that the element is not found. Return the element is not found. Okay, let's save this and run this for any given value to see that if our function is working properly. So I will do like this, search to the array. We will search inside this array. As the first parameter, I will put it here. Then let's search for a 14, value of 14. Let's see what will happen. We know that we have 14 in our array, so it should return something. Let's see that if this function will return the index that is belong to 14. So let's run our function. It's not returning anything because we haven't printed the output from here. Let's print it. Let me save it. Let me clear this one. Let's run it. This is our array, two-dimensional array. I've just printed out from here to see it clearly where is our element is located. And it shows that the value that we are looking is located at index 1 and 1. What does it mean 1 and 1? 1 means that it's the index of row is 1 and the index of column is 1. Let's see. So this is the 0 index row over here. So this is the index of 1 row. So this is our row. Here we are going to look for 14. And then this column over here is the bit 0 index, and this is with index 1. So it should be somewhere here. So 1 and 1, as you see, the value of 14 is over here, which means that our function works properly and shows the location of 14. Take into account that this function will return the first occurrence of 14. As you see, we have another 14 here. So as soon as this function finds the first occurrence of the 14, it will return this location. So let's see if we put any value that does not exist in this list, what will happen. Let's put, for example, 55. Let's save it and let's run it. As you see that it returns that the element is not found. So this is how we are searching inside two-dimensional array for a given value using linear search. So what is the time and space complexity for this operation over here? If you start from here, we see that we have if condition here. The time complexity of if condition is O1 time complexity, and accessing an element of any given array is O1 time complexity, which means that this if condition over here will be O1 time complexity. So let's continue to the next loop, which is the inside loop. Here, this will take On time complexity, and the n is the number of columns. So then we are continuing to next loop. We know that if we have nested loop inside each other, this will be OMN time complexity. Because here, even though we are looking inside same array, the number of columns and the number of rows might be different. In this case, if we have number of rows equals to number of columns, then this will have quadratic time complexity. Otherwise, it will be OMN. In this case, we see that we have 1, 2, 3, 4 column and 1, 2, 3, 4 row, which means that for this function, for doing a search inside this particular two-dimensional array, the time complexity will be quadratic. But if we have, for example, different number of rows, then the time complexity will be OMN. The space complexity for this one more time, will be O1 time complexity because an extra memory is not required for performing this operation. Hi there. Now in this video we will look at how can we delete a row or a column from two-dimensional array. Let's say we have an array like this. So we want to delete first column from this array. So how this is going to be possible? So to delete a first column from this array, we need to access this first column and delete its elements. So what will happen after deleting this column from here? This location will be empty. So we cannot keep this location empty in two-dimensional array. So this column over here has to move to this place of deleted column, and this column over here has to move to this place. So as you see, each column has to move one step left. And this process is very time consuming because every time when we delete a column, the rest of columns have to move one step back. And this is how deleting a column in two-dimensional array works. So let's see what is the time complexity of this operation. As we said, when we delete a first column from here, each column has to move one step left. So which means that, for example, if we have n number of elements here and we have m number of columns, so each column has to move n number of steps to the left. And in each column we might have m number of elements. This means that m number of elements have to move n number of steps to the left. And the time complexity then will be OMN. If the column number and the row numbers are same, then this will be quadratic time complexity. Now let's see how can we delete a row from two-dimensional array. So let's say we have an array like this and we want to delete first row from this array. In this case, what will happen? When we delete a first row from two-dimensional array, the second row will move to the place of first row, third row will move to the place of second row, and it will continue like this. So as you see, this is also a very time-consuming process because every time we have to move the rest rows one row up. So the time complexity for this operation also will be OMN time complexity. Because if we have n number of elements in a row and we have m number of rows, we have to move these elements m number steps to the top. So that's why the time complexity is OMN. Once again, if the row numbers and the column numbers are same, then we will have quadratic time complexity. Now let's see how this is working in practice. Let's one more time switch to Visual Studio Code. Okay, here let's see how can we delete a column or a row from two-dimensional array in practice. As you remember, when we create this two-dimensional array, we said that this is very useful to use NumPy module. So to delete a column or a row from a two-dimensional array, this module provides an efficient way of doing it. So it provides us a deleting function. So we can use this function without creating any function to delete column or row from two-dimensional array. So what I'm going to do here, I'll create new array, new TD array, and call NumPy delete function, because this function returns new array with the deleted columns. So here, first parameter will be the array in which we want to delete column or row. So the second parameter here, the index of row or column. For example, if I want to delete first column or row, I need to put 0 over here. As we said, the index starts from 0. Then the next element is access element. You remember we talked about this parameter. This parameter shows whether we want to delete column or row. If we put here equals 0, it means that we want to delete first row from this array. So I will print out newly created array to see how this is working. In this case, it should delete first row from the array. Let's run our function. So this is the initial array we are printing over here. And as you see, the second array is showing that the first row from initial array is missing, which means that we deleted this row. And the next row moved one step up, and the other row also moved one step up, and each row moved one step up. So this is the new array with deleted row. So if I change the parameter, for example, to 1 here, and rerun our code, we see that when we change the parameter access to 1, it deletes the first column. This is the first column from the previous array, and you see that now the first column is the second column of previous array. For example, if we change it to 1, it will delete the second column from the array. You see that the first column remains same, and it deletes the second column from previous array, and the third column becomes second column, and the fourth column becomes third column. This is how deletion works using NumPy model for two-dimensional arrays. As we said before, the time complexity for this deletion is OMN, where n is the number of columns and n is the number of rows.
So if we have same number of columns and rows, this means that the time complexity will be quadratic. And here, if we delete the last column or last row, the time complexity will become O1, because we don't need to move any row or columns in this case. So the efficient way of deleting any row or column from two-dimensional array is to delete the last column or the last row. And as always, the space complexity will be O1 because extra memory is not required to perform this operation over here. So that's it for deleting a column or row from two-dimensional array. Hopefully everything is clear for you. Now in the next lecture, let's see what is the time complexity of whole two-dimensional array. Hi there, in this video we will look at time and space complexity in 2D arrays. So we will look at each operation that we performed on two-dimensional arrays and their time and space complexity. Actually, we talked about these operations in previous lectures and we explained the time and space complexity of these operations. But here I just want to combine everything together to show you the big picture of time and space complexity in two-dimensional arrays. Let's start from the first, creating an empty array. So creating two-dimensional array takes constant time complexity, and the space complexity will be OMN. This is the M is the number of columns and N is the number of rows. So we need to allocate number of columns and rows in the memory for our elements in two-dimensional array. So that's why space complexity is OMN. Let's continue to the next operation. The next operation is inserting a column or row in an array. So if we are inserting a column or a row at the end of array, this will take constant time operation, because in this case we are not moving any row or column to the right or down. But if we are inserting, for example, a column in the beginning of array, then each column has to move one step right. This will take OMN time complexity. Similarly, if we insert a row in the beginning of two-dimensional array, each row has to move one step down. That's why the time complexity will be OMN. The efficient way of adding column or row in two-dimensional array is adding it at the end of a two-dimensional array. The space complexity for inserting a column or row in an array will be constant because we have already allocated memory for this column or row. So an extra memory is not needed to perform this operation. So the next operation is traversing a given array. We showed you before that traversing means that we have to visit each and every element of array. This means that if we have m number of columns and n number of rows, the time complexity will be OMN. In case the number of columns and rows are equal, then the time complexity will be quadratic time complexity. For this operation, we don't need any extra memory. That's why space complexity is constant. Then accessing a given value. We know that accessing a given value in an array is very efficient. That's why the time complexity is constant time and the space complexity is also constant. Because based on index, we can straight away identify the location of any given element in an array. So this will not take too much time to access this element over here. Then searching a given value. If we are using linear search, then the time complexity will be OMN. Because here, one more time, we are checking each and every element of array to see that if this is the value we are looking for or not. And space complexity is constant because we don't need any extra space to perform this operation. Then we continue to deleting a value. So if we are deleting a given column or row from the end of two-dimensional array, then the time complexity will be constant, because in this case, we are not moving any column or row to right or to up. But if we are deleting a row from the beginning of two-dimensional array, then other columns have to move one step up. And this means that this will take OMN time complexity. Similarly, if we are deleting first column from the two-dimensional array, the rest columns have to move one step left, as we showed you in our previous lectures. So this will take OMN time complexity. And this is it for two-dimensional array. Hopefully you have a big picture of time and space complexity in two-dimensional array. Alright guys, this is our final lecture on arrays. So till now we have learned different features of arrays, and we learned how to implement them and how can we perform different operations on given arrays. So here we will learn when it's useful to use arrays and when we have to avoid them. First of all, let's see when we can use arrays. The first case here is when we want to store multiple variables of same data type. This means that, for example, if we want to declare thousands of variables of same data type, we don't need to declare them one by one. We just need to create an array of, for example, an integer and create 1,000 variables inside this collection. So this is very useful when we have to declare multiple variables. Now the second useful time to use an array is when we want to access random numbers from given arrays.
This is mainly because any given random number from the array takes O1 time complexity, which is very efficient for our software. Imagine that we have an array of thousands variables and we want to access a variable from the middle of the array. If we use different data type, this will take O(n) time complexity because we have to traverse from the beginning of the list till we reach the array that we are looking for. But in terms of arrays, it will take O(1) time complexity because by knowing the location of the element in the array, we can straight away access it, and this is very efficient in terms of time complexity. Okay, let's see when the usage of an array is not useful. In this case, we need to avoid usage of array. The main limitation of an array in some programming language is storing same type of data type. In last versions of some programming language, this limitation is solved, but in some programming language, it's still a problem. This means that, for example, if you want to declare variables of different data types, so for each data type, we need to create separate arrays. And this is a limitation in array. And another limitation is array reserves a specific amount of memory to hold its content. Maybe it reserves a memory that will not be used in the future, but it takes memory in our RAM. This also causes another problem when you add elements to an array and array begins to exceed its reserved capacity. In this case, the array allocates a larger region of memory and copies its elements into the new storage. And this in turn affects the performance. So the performance of our application affects very badly. So with this lecture, we have come to the end of the discussion of arrays. Hopefully everything is clear about the arrays. If you have any question regarding this array section, please do not hesitate to contact me. Now in the next section, we will discuss lists in Python. See you over there.